Hi everyone, welcome to the CloudStack India User Group meetup. So let's get to the agenda. So we have two halves. Before lunch, we'll have intro to CloudStack, what's new in CloudStack. We have Dilip Singh, who will present about his CloudStack journey. Then we have a presentation on VMware to KVM migration. After lunch, we'll have talks on some demo-heavy talks on some of the new features which has come in 4.19. Then we'll have talks on tooling system and authentication methods. So this is the event which we are having today in Hyderabad. So these slides is about the events that we are having for the CloudStack community. The first one is we are having today. Yesterday we had an event in Amsterdam, Ceph and CloudStack Day. Upcoming events which we have is we are planning a CloudStack collaboration conference in Madrid in November, and we are planning a CloudStack India User Group meetup in Delhi NCR at the later part of the year. Some thanks for this event. We want to thank Quality Metrics and Shashikant for the venue. We also want to thank some organizers and helpers, especially Venkata, Evith, and Jamie. And a lot of thanks to the speakers, presenters, sponsors, and everybody in attendance today. So please give yourselves a warm round of applause for joining us. Okay. Feel free to post anything or any pictures or anything you want using these hashtags. Okay, so let's get started with the talks. So the first one, Rohit will present. Rohit is a long-time committer to the project, PMC member, and currently is the serving vice president. So please help me invite Rohit Yadav to the stage.
Just double check things in place. All right, good morning everyone. We had some delays, but I hope you didn't have a lot of trouble finding the venue. So like Abhisar mentioned, let me first of all thank all our sponsor helpers for who helped organize this meetup, and let me take some moments to introduce about CloudStack. So this talk is actually about what is CloudStack, what are the use cases, what it's for, and what can you do with this. A bit about me, like Abhisar said, I've been a long-time contributor, PMC member, and a committer of the project, and currently the VP of the project. I'm also leading and organizing the CloudStack India User Group meetups, and at work, at my day job, I lead the engineering function at ShapeBlue, which is an employee-owned company. We are one of the largest integrators of CloudStack, and we work in IaaS design, consulting, training, support, and engineering services. All right, so we are here, and this talk is about CloudStack. So a quick show of hands. How many of you are using CloudStack or have deployed or played with CloudStack? Okay. A few. How many people are using some sort of cloud orchestration platform, maybe in their organization or? Okay, excellent. And how many of you have not heard of CloudStack earlier? Okay, a couple of people. So this talk is actually for anybody who's looking to learn about CloudStack, is new to CloudStack, and wants to play about CloudStack. So I'll basically read out what is CloudStack for you, and we'll dissect what it actually means. So CloudStack is a scalable, multi-tenant, open source, hypervisor agnostic cloud orchestration platform for delivering IaaS cloud. What it means is it's highly scalable, it supports multiple customers or tenants, it is open source, and we have deep and broad integration with a lot of hypervisors. In terms of what type of use we have is we started with a lot of sort of to replicate what AWS would provide on the public side. So CloudStack started as a tool for service providers. So we saw a lot of use cases in the public cloud usage. And we also saw a lot of enterprises adopt CloudStack for their own private cloud. And these days, we are also seeing hybrid setups. We are also seeing edge cloud setups. In terms of what are the building blocks and what it does, I suppose many years ago, this is what the AWS stack would look like. AWS or Amazon, an e-commerce company, would use bunch of components, networking, compute, and storage components, and it will use a hypervisor. So AWS forked Zen server or Zen project, and they had their own hypervisor, and on top of it, they wrote their own orchestration layer, and of course, their orchestration API, and we know that is what powered their e-commerce website. And Amazon, as you know, sells on their e-commerce platform books and CD-ROMs and what have you. So CloudStack kind of was started in that image, and CloudStack also took the same network, compute, and storage components. And instead of one specific hypervisor, we have deep and broad support for multiple hypervisors. And of course, CloudStack is the cloud management platform, the orchestration layer on top of the infrastructure beneath. CloudStack has its own API. CloudStack has an excellent UI, and of course, there are third-party e-commerce platforms that can run or can be developed on top of CloudStack APIs. And of course, it has a CLI. We have support for Kubernetes service, and we have multiple support for Kubernetes engines. And one of them is CAPC, which powers some of the commercial offerings like EKS-A, support for dev tools like Terraform, Ansible, a lot of automation use cases, and multi-cloud management systems. This is more recent diagram, a sort of prettier diagram than the one that I showed you. So I'll give you a moment if you want to just go through it. So why CloudStack? So why should you use CloudStack or consider CloudStack? So first of all, it's a turnkey project. It's an integrated end-to-end IaaS product. In the open source space, there are a few other cloud management platforms. Compared to that, it's a turnkey project. It's not a jigsaw puzzle that you have to put together to make it work. It's proven at scale. It has widespread adoption. We'll come to the adoption bit in a second, but CloudStack, the largest CloudStack cloud that I know of, had about 50,000 hosts. And it's very common to see CloudStack environments which have like 4,000 to 5,000 hosts. Some of the organizations I work with have that sort of scale. So CloudStack is proven at scale. It's really easy to get started with CloudStack. You can build a POC cloud in less than a day. So it's rapid time to value. Overall, it lowers the total cost of ownership. So low implementation and operational cost. You don't need a huge team to manage and run your CloudStack cloud. I know some of the large CloudStack environments which have these 4,000 to 5,000 hosts managed by a single person or a 2-person team. It's truly multi-tenant. The project is open source and it's user-led. It's community-driven. So there's not much vendor involvement, and it's completely governed by the ASF, which is the Apache Software Foundation. It has easy integration of what I say narrow scope, which means CloudStack doesn't try to do a lot of things. It integrates with other technologies, your compute, storage, and network components. So it doesn't try to become a hypervisor. It doesn't try to become a storage provider. It integrates with them. That means it's easier to integrate with your cloud infrastructure, but that also means it's got a narrow scope of what it can provide to you. And as I said, it's a free and open source technology. It's an enabler technology. Let's look at some of the advantages you get with CloudStack. As I said, it's got a broad and deep hypervisor support. Here's a list of hypervisors we support. Among them, KVM, VMware, and Zen Server seem to be community's favorite. We have broad and deep support with this, but among others, we also support these three. It's got enterprise-grade multi-tenant virtual network model. So it has the flexibility, so you don't have to think about network elements, routers and switches. CloudStack will manage a virtual network infrastructure for you. It's highly scalable architecture. It supports thousands and thousands of hosts And in some cases, we have seen millions of virtual machines in a large CloudStack environment. It's highly available, so you can have multiple CloudStack management server control plane running, and it gives automatic failover to your virtual machines in case of failure. It's got great user self-service, so end users can use the UI, the API, the CLI, or write their own automation integration using the REST-based API. It's got excellent support, in fact, multiple support for Kubernetes in form of CKS and CAPC, that is a component used by EKS-A, that allows and gives you seamless container as a service offering. Of course, there are tons of great features, and in this meetup, I hope you get to see some of the demos of the excellent new features that are coming in the latest version of CloudStack. Lastly, we support a range of dev tools like Terraform and Ansible and what have you. So the question is, who's using CloudStack? So among the users, publicly known users of CloudStack, here's a small list of people. Many of the people in the meetup may be from these organizations. However, there are many more. Being an open source project, we give away the software and we don't track usage. So it's hard to say who's actually using CloudStack. In fact, some of the organizations I work with are users of CloudStack. They are very large users of CloudStack, but they, for one reason or another, they don't want to say they're users of CloudStack. To give you an idea, two of the world's largest companies by revenue, let me repeat, two of the world's largest companies by revenues are users of CloudStack, but for one reason or another, they get upset if I put their logos on my slide. But there is a way. We have a public website where user organizations can say, put our list on the website, and we put that. So far, we have more than 200 known user organizations and companies that are users of CloudStack. We also have a community packages server. So we build package of CloudStack and we host it there. And from the log analysis of that, we know CloudStack was downloaded in the last 12 months, more than 200,000 times. So clearly, the universe of CloudStack users is much more than the known universe of CloudStack. In fact, we use this data to put it in a map. This is data for the last 36 months, because not everyone installs CloudStack every day. And you can see CloudStack users are everywhere. They are everywhere across geographies, across countries and continents. So let me take a moment to show you what CloudStack is, and then maybe we'll talk about its architecture, its history, some advantages, and how the community functions. So this is what the CloudStack UI portal looks like. This is a home lab cloud that I install. So I'm going to log in as a normal user. CloudStack has multi-tenants, and those tenants might have different roles. I'm trying to log in as a normal user, which would be the end user who's consumer of your cloud. When I log in, I usually go to the dashboard. Let's see if I would have to apologize and pray to the demo gods that I don't screw up here. And if some of you are on Wi-Fi, I may request you get off Wi-Fi so I can have my demo. Thank you. So this is what the dashboard looks like. In the dashboard, I can see what are the different resources, compute, network, and storage resources I have. What is the capacity and limits I'm allowed to deploy, the number of VMs, volumes, and instances, and what have you. So I'm going to head to instances, because that's one of the four primary things you would do when you use a CMP. You want to deploy a virtual machine. Here are some of the VMs I've already launched. And I said this is my home lab cloud, which I'll talk about at the end of my demo, why I use it and how I use it to save money. So here, I'm just going to go and click on Add Instance. And this is your instance deployment form. I have to select my zone. So like typical of any hyperscaler, any CMP you may have used, you'll be given a list of zones, availability zones that you can select. I have only one, so I select this one. Next, I can select a template. So I've got a list of templates. I've got Ubuntu, Debian, Alma Linux, Alpine Linux, OpenSUSE, FreeBSD. This is something I expect the operator or admin to add for me. So I can select any of this. If I don't want to use a template, I can select an ISO, so I can select my operating system of choice. I can select that. So let's go ahead and just select Ubuntu because that seems to be a very popular offering a lot of people use. Once I've chosen my template, which is like an image, I have to use a plan, my compute plan, what we call a compute offering. So let's go ahead and select this one that gives us 4 CPUs and 4 gigs of RAM. And here I can also override root disk offering. So the root disk on which the operating system installs, I can say, okay, let me have 50 gigs of space in it. In addition to the root disk, you can also add a data disk, an optional data disk, which can be of any of this size. I'm going to skip it for now. In terms of network, I can either select a public network, which means my instance will get an IP address on that public network, or if I need a firewall, a network device that can do a bit of NATing and firewall and port forwarding and load balancing, I can select that. So let's first deploy on a public network. Then I can select SSH key, so I can like SSH into my instance. There are some advanced settings that allow you to change the boot mode between BIOS and UEFI. You can specify your user data, all these templates, if they are Cloud Init based, you can put in the data here, and you can put in affinity groups if you want that. And we can put in a name, so let's say, we'll say meetup VM1 and click on launch instance. As soon as do this, in my environment, this is KVM based, so this is supposedly very fast. And the underlying storage is NVMe based local storage. So as soon as I click deploy, it deployed really fast. I can go click on my VM. And here I see bunch of buttons, which are very obvious. You have probably seen it if you've used a CMP before. Let's see the console, for example. So this is the VM console. If you know the username password, you can access your instance through the VM console. Or there are other operations, like you can stop an instance, you can reboot it, you can reinstall the OS on your instance, you can take a snapshot, and you can attach an ISO. Here we see some information about this virtual machine, from which image it was deployed, what is the configuration of my VM, what is the IP address. Some metrics can show up here, volumes, NICs, snapshots, backups, settings, and events, and I can also put in comments if I want. Let's copy the IP address, and what I'm going to do is, because I've already specified my SSH key, so I can SSH into my instance. Let me increase the font size. So I'm actually inside my VM, and if I say htop, you can see it's got 4 cores and 4 gigs of RAM. And of course, I can do whatever I want. I can install some application, reach out to the public internet, and what have you. So that's the instance. I can also create Kubernetes clusters for me. So I can like create a Kubernetes cluster, give it a name, select a version, select the offering, the disk size, select the network, give how many number of nodes, worker nodes I want in my Kubernetes cluster. I've deployed one. I had to just sort of save time in my demo. So I've got a Kubernetes cluster here. I click on it. And if you're downloading anything on the Wi-Fi, please stop. Okay, so this is the Kubernetes cluster. I can see the spec of this cluster. I can see the number of nodes, the worker node and the control plane nodes in my cluster. I can see details. I can see how to access it. So there's a kubeconfig file that I can download. How do I use the CLI to access my cluster? So I've set it up already. So just to show you an example demo, I can say kubectl get pods -a. So you can see my Kubernetes cluster is running. And just to verify that I'm not fooling you, I'll say kubectl get nodes -o wide. So you can see the IP address is 10.10.110. I can double check from here. So that is an example of the things you can do. Of course, there are other options. You can add an SSH key. You can put in your user data. You have affinity groups in compute. Let's change gear and look at what are the other things you can do in terms of storage. So starting with storage, these are the various volumes of your virtual machine. So let's just go to one of the volumes of the VM we just deployed. Here we can see the details of this volume, and I can perform some operation like I can detach, I can take a snapshot, I can have recurring snapshot. Let me actually show you an actual VM that I use in my environment. So this is sort of a pet VM. and you can see events and comments, and you can see it has recurring snapshots. So I've scheduled like a weekly snapshot on it. What recurring snapshot does is it allows you to take an automatic backup at user provided frequencies. You can take hourly, daily, weekly, or monthly snapshot, and that way those snapshots are essentially backup of your virtual machine's disks, so you can restore them easily. In order to see snapshot of a VM of a volume, you can see view snapshot. So these are 3 snapshot, and I can see the time also. So I've a weekly last 3 weeks snapshot that I can revert if I mess up, I screw up my virtual machine. So those are the snapshots. VM snapshot are similar, but they can also capture the RAM, the memory also. So and VM can have multiple disks, so VM snapshot can snapshot the entire virtual machine for you. We also have support for backup. I don't have it configured in the lab, but we do support for KVM, we support Dell EMC Networker. For VMware, we support Veeam. And we have an upcoming KVM support that uses BOG backup called DIMSY's Backroll. So that's coming in the next version of CloudStack. In terms of networking, there are different type of network topologies you can create. These are virtualized, so CloudStack creates virtual network infrastructure for your workloads. If you need a firewall, you can create a private isolated network. If you need a flat L3 network, you can create a shared network. So in order to do that, you can create a network. If you need a firewall, you select the isolated network. If you only need L2 isolation, like a VLAN based network, then you can create this also. And you can, if you want a shared network, you can sort of create a flat shared network here also. So if I go to a network like public network, you can see what are the VMs deployed on that instance. Of course, we support VPC. So in case of a VPC, it's like a multi-tiered, isolated sort of network in a sense, where you have multiple tiers. Those tiers are isolated by some sort of isolation mechanism like VLAN and VXLAN. And you start with the superseder, and then you create tiers out of that. So in this example, I've got this sort of a seeder, and in my VPC, I can create a network within that. So let's say I say create tier 1, and let's say the gateway is 10.1.1.1, and net mask is your typical /24, and I can say the default ACL, so like traffic is allowed. So you can create multi-tiered VPCs where typical 3-tiered apps, where database, your front and the backend servers can be put there. And of course, you can have VPN in case of an isolated network like a private network. You can have firewall rules, your egress rules and ingress rule. You can have public IP address you can acquire, and within that IP address, you can have firewall rules, port forwarding, load balancing, VPN, and all other services that you would expect CloudStack or any CMP to have. Next, we have support for images. So you can have templates. You can see all the admin configured templates that are in the environment, and you can just upload depending on the hypervisor of choice. You can upload your own templates also. Like in this case, this is a template I uploaded as a user, and I can also see templates that the admin of the cloud configured for me. Similarly, you can have ISOs. I haven't uploaded any ISOs, but the admin has uploaded some ISOs that any tenant in that cloud can use. So in this case, I can see some ISOs that are uploaded here. Then we have a notion of projects. If there are multiple tenants in a CloudStack cloud, multiple accounts can join a project and they can do things. For example, I've got a CloudStack lab project. So I can, on the drop down at the top, I can select that group or a project. And then I can see what are the instances in that specific project. And projects have their own dashboards also. Of course, I can see account information, and I can go to my user account from which I've logged in. I can copy my API secret key if I need to do some API automation. I see zone specific information. I need service offering specific information. This is really useful if you're automating your cloud deployment. You're using tools like Ansible, Puppet, Chef, Terraform, and Kubernetes, and what have you. So I hope that gives you a short and quick demo of what CloudStack can do, what the UI looks like. I'm just going to a quick demo of what the admin account also looks like. So as an admin of a CloudStack cloud, of course, your view of your infrastructure changes. In the dashboard, you see an infrastructure overview of what compute, network, storage resources I have, what network attributes and properties I have, events and alerts I have. Rest of the things are same, but now I see more or less infrastructure. So I can configure zones. I have pods, which are racks, clusters, hosts, primary and secondary storages, and I've got system VMs, the virtual router that implements the virtual infrastructure in CloudStack, and so on and so forth. So I hope that gives you a rough idea of what CloudStack can do for you. Let's just head back to our slides. So whatever you saw in the API, like the VM deployment, listing of the VMs, all those things you can also do through APIs. This is just to illustrate the point that all these things you can do in the UI, you can also do through API. Here's some examples of listing a VM, creating a network, and then deploying a virtual machine on that network. And we have an excellent API doc, so anybody can go to CloudStack API docs to discover and learn about those APIs, what parameters those APIs accept. Now, APIs have huge advantages for people. So I'll start with users. From a user point of view, whether you're using CloudStack from a public cloud's point of view, a hybrid cloud point of view, an edge cloud, or your own enterprise private cloud, APIs provide users to create scalable infrastructure for other layers. We see a lot of adoption of CloudStack with Kubernetes users, people who want to use Terraform, people who want to use Kubernetes, and they have a use case and they build infrastructure on top of CloudStack. People can script, build, and tear down their R&D, their research and test environments. A lot of times when organizations want to go public, they can't spend that resources, the time, money on public clouds because they're expensive. So a lot of times they have a private cloud use where they use their test and automation environments in-house. And when they want to go live, they go live on one of the hyperscalers or one of the service providers that use CloudStack. We see a lot of automated deployment of baseline production because a lot of times, CI/CD is a good example. You want to build your infrastructure from scratch, do some tests or maybe create demo environments for your customer or deploy applications at large scale. So those are the areas where CloudStack can be useful. Automated deployments of disaster recovery environments is also useful with CloudStack. From an enterprise and operator's point of view, CloudStack allows creation of custom multi-tenant portals. A lot of people want their own portal. They want to sell cloud. So CloudStack APIs allow you to do that. A lot of people can have their business and billing integration on top of CloudStack also. Just like the UI and the API, there's also a CLI. It's called CloudMonkey. And all the things you can do in the UI and API, you can use through the CLI also. I'll show you a quick example with CloudMonkey. So I can list virtual machines, and I'll say something like this. It logs in and returns a JSON. Of course, I can set the output to one of many options. So let's say we say a table, and I'll say, let's just get the name and their IDs. So I can do a lot of those things with the CLI. Let's talk about the CloudStack architecture. So the obvious one is compute. We have broad support and deep support with a lot of hypervisors, including bare metal. Of course, the first three are the community choices. So we have broad support and deep support for all these hypervisors you would expect. We support plethora of primary storage and a lot of deep integration through managed storage with commercial vendors. Some of them you may recognize from this slide. Then we have support for secondary storage. So primary storage is that fast storage you need for your instances, and secondary storage is relatively a sort of degraded version of your storage. Now, oftentimes it's a cheaper version of this. Among other options, Swift and S3, NFS seems to be the most popular choice with CloudStack. And with in the latest version of CloudStack 4.19, we also have support for object storage, starting with MinIO that ships with 4.19 and an upcoming support for Ceph. So object storage can also be provided through CloudStack. In terms of networking, these are the things you would expect from a CMP. We support advanced L2 and basic L3 services. In the L2 network model, you have isolation support with VXLAN, VLAN, GRE, and so many more. And your basic L3 is a flat network where you have, just like Amazon, you have security groups, which in case of CloudStack are essentially firewalls on the host where your virtual machine runs. And like you would expect, these are the various services like routing and firewall and DHCP, DNS, load balancing, VPN, port forwarding, and even much more. This is what a typical CloudStack deployment might look like. Before I talk about the deployment model, I should talk about some concepts and terminology. So these are the constructs of CloudStack. A CloudStack installation is called a region. Regions are separated, they're isolated with other regions. So in this example, let's say the region is APAC. I've installed CloudStack for my region. Within a region, you can have zones, what AWS calls availability zones, we call data centers or zones, and you can model them however you want. Within a zone, you have pods or racks, and as you see in data centers, racks have hosts or cluster of hosts, a bunch of hosts. So in this example, you can see a cluster of VMware and KVM, and within a cluster, you have actual physical host where your hypervisor runs, and in the rack itself, you can have a primary storage. On the zone-wide level also, you can have primary and secondary storage. So this is typical of what CloudStack construct and deployment would look like. This is the same diagram, but done in a slightly different way. And the important thing here is to notice that the management server, the CloudStack control plane and database are just some entities that are not in the data path. This means you can install, you can upgrade, you can shut down, you can pull the plug of the CloudStack environment. Your infrastructure will still run. There's nothing will happen to your infrastructure. In this example, we can see with the network elements and devices, there's a cluster of hosts where a pod, which represents a rack, many racks may run your workloads. And in this case, if you shut down your management server, nothing will happen to your environment. Let's talk about the CloudStack community. Before I do that, I think I should give a bit of history of CloudStack. So we have deep-rooted pedigree and history. The project actually started in 2008 by a company called VMOps that got renamed as Cloud.com. Citrix later acquired Cloud.com in 2011. And later in the next year, 2012, Citrix donated CloudStack to the ASF, to the Apache Software Foundation. The next year, it became a top-level project. If you know Apache, you probably heard of Kafka or Cassandra, Hadoop, the Apache web server, for example. So those are all top-level projects. CloudStack became one of those top-level projects. And from 2014 onwards, majority of committers, majority of people who are developing CloudStack were not from Citrix. In fact, in 2016 and onwards, Citrix left the project. And since then, CloudStack has continued to grow in terms of feature set, in terms of number of releases, meetups, and events. It's a very growing community. CloudStack now is developed by the Apache CloudStack community. So there is no single vendor. It's not vendor driven. It's a diverse user driven community. It's very important because vendors don't have things to say, which means users are aligned in their end interests. The community is governed by the ASF. We try to do 2 major releases in a year. Of course, there are maintenance releases also that happen in a year. We do LTS releases also. The diversity of user-driven community ensures that no single vendor can influence the direction of the project. So you're not dependent on the mercy of a single vendor. We are noticing both in the commercial and the open source ecosystem, some of the FOPA vendors, open source vendors, have decided to go a different path, which has affected users. You know what I'm talking about. You all are affected from the RHEL, CentOS thing that happened. You all may or may not be affected from the VMware. So it's always a good idea to not be vendor dependent. You want in your open source, in your cloud strategy, to be not dependent on a single vendor. And CloudStack and the governance model by ASF ensures that your business interests, your user interests are secured. This is to give you an idea of how the ASF works. There are users or contributors of a project. This is not specific to CloudStack. It generally applies to any top-level Apache project. So users and contributors are people who use software, they report bugs, they are participating on their users mailing list, coming up with their problems, sharing and helping each other. Some of the users and contributors who are committed to the project longer term, they get invited to become the project committer. They need not be developers. Of course, contributing, developing code, fixing a bug is the obvious way, but there are other ways to contribute to an open source project under the ASF. For example, you can submit bug fixes, you can be on the users mailing list, learn from other users, help other users, you can help improve the project documentation, the website, you can organize meetups and events, you can go and evangelize a project of your choice and say, I'm using CloudStack or I'm using one of the other Apache projects. These committers get access to certain privileges to access the code and commit and do those things. When a committer is contributing on a sustainable basis longer term, is contributing to the governance and decision making of the project, they can get invited to be part of the PMC, the Project Management Committee. The Project Management Committee reports to the ASF board and is tasked, is responsible for governing and deciding, making decisions around a project. So the CloudStack community today is a diverse set of committers and PMC members. We have a very busy GitHub and mailing list activity. You go to a GitHub, every week I see somebody new that we haven't heard of, they're reporting bugs. That means people are using CloudStack. Just to give you some statistics and idea, we are doing thousands of packages downloads on a weekly basis. We have we've crossed 1,500, 1,600 stars on GitHub, if that's a stat you would care about. In the last 4 weeks, we see more than 100 activities on the various PRs. So some of them got merged, some of them got opened. Similarly on the issues, right? More than 100 issues are being reported. This is just monthly statistics. And you can see, excluding mergers, there are 35 authors. So on a sustained basis, between 35 to 50 developers, code contributors are contributing, maintaining, improving CloudStack, writing features for CloudStack. In the last 15 days alone, this is statistics from GitHub, we saw more than 2,000 unique visitors who are visiting CloudStack, forking the code, contributing to the code and whatnot. And like Abhisar in the beginning showed some of the recent and upcoming events, we are seeing lots of meetups and events, both in India, across the globe, and what have you. So I hope with this talk you got an idea of what CloudStack is, what it does, how you can benefit from it. Now the question is, where do you go next? Where do I go next? How do I try it? I think the first thing is go and try CloudStack. Go to the project website, explore the website and all the pages. Go to the download section, try CloudStack. We also have a documentation you can go and read. There's a quick install guide that you can try. Typically takes anywhere from few hours to less than a day to set up CloudStack. The deployment model I showed you can do all in a single box. So in a single VM running, which has the necessary CPU instruction, you can install KVM, you can install everything on a single box. If you don't want to install CloudStack, you can still try CloudStack. We have a simulator, which means we simulate the hypervisor, compute and network storage resources for you. And if you go to the simulator, you can play with the UI and API. It just takes a couple of minutes. Go to the page, qa.cloudstack.cloud/simulator. The username and password are mentioned on that page. You log in, you play around the UI and API, you get a feel for the product. Of course, I encourage everyone who's interested, go and join the mailing list. The users mailing list is a good starting point, but also GitHub. So from the project website, you'll get linked to the GitHub page. Go and see the issues, see the pull request. You can start a discussion. So we also have a discussion, which is a forum style mechanism where people can ask questions, get answers. And of course, we have events and meetups like this. So you join them, you learn more about them, and you can even, if you're users of CloudStack, you're welcome to present and give talks about CloudStack. So that's it. With this, I thank you for your time, and I hope you learned a bit or two about CloudStack. I'm open for any questions if you have.
Is CloudStack planning for any project where database as a service can be provided to users?
Okay, thank you for the question. So the question is, can CloudStack do database as a service? So the answer is there's a lot of discussions coming in. We have a feature called user data as a first class feature. So you can sort of create a database as a service through the Cloud Init customization, create a template, you can do that. We don't have an integrated feature called database as a service feature, but it's possible to come up with templates that are linked with the user data, and maybe we can take it offline. So maybe some of our engineers can show you how you can do that. Thank you.
what CloudStack having better features when you compare with public clouds?
Sorry, say that again.
What CloudStack having a better features
Right.
when you compare with public clouds? Like
So,
AWS,
right. So the question is, how does CloudStack differentiate against hyperscalers like AWS and GCP and what have you? So I would refer back to the key advantages section. One of the thing is it's free and open source. Anybody is free to take the software, set up their own cloud. In terms of feature set, the core feature set, there's parity. All the core functionality you would expect: access to compute through instance and Kubernetes, access to storage in terms of volume, backup, snapshot, and imaging services like templates and ISOs. We have all of that. What we don't try to do is to do everything that hyperscalers do. You go to hyperscaler, they're a large shop and they have everything as a service. They've got queuing as a service. They have name it, and they have some sort of offering. CloudStack simply tries to have a narrow focus, and we do well is cloud management platform. So I hope that answers your question, but the simple thing, it's free and open source. It gives you that flexibility because in future, if hyperscalers suddenly start to charge you more and all your infrastructure and data is there's going to be a lot of issues. In fact, this is something we are seeing in the community. You call it cloud repatriation or lowering the total cost of ownership. A lot of people who are users, hyperscaler users, they're considering CloudStack and alternative technologies because of this. They want to be in control of their own company strategies or user organization strategy, and they want to lower the total cost of ownership. Thank you.
Just an extension of this question. So basically, you have one of the comparison. I mean, you have OpenStack, right? So how do you see the difference between OpenStack and what CloudStack offers?
Okay, thank you for the question. So the question is, what's the difference between OpenStack and CloudStack? I think OpenStack is more like a framework. It's like a jigsaw puzzle. There are many components. OpenStack has a place and use with organizations. So does CloudStack. I wouldn't say one technology is better than other. What I'll say is these are open source technologies. Go and play with it. What I can assure is with CloudStack, you can set up a functioning cloud in less than a day. I can't say the same for OpenStack and others. The other problem comes with regular maintenance and support. With CloudStack, a small group of people, maybe just one person or two person, a small team of people can manage, operate your CloudStack based cloud. So you're lowering the total cost of ownership and also maintenance and upgrade costs. CloudStack is also easier to upgrade since it's a monolith, it's a single service. Taking backups, upgrading it is not a hassle. Compared to OpenStack, which is like a jigsaw puzzle, you have to put together, you have to plan your upgrades in advance. And both technologies have their own use cases. So I wouldn't say one technology is better than other, but I would say these are the niche advantages that you get with CloudStack.
If you want production kind of support.
Sorry?
If you want any production support.
Yeah.
For CloudStack. So do you require to pay any license?
Right. Thank you for the question. So the question is, for product support, where do you go? Where do you get product support for this? So the first answer is CloudStack has a vibrant community. We see a lot of people who support each other through users mailing lists, through community, and people form their own niche groups where they help each other. Just like on Stack Overflow, on Reddit, we have that sort of community. The second one is, of course, vendor-based support offering. For example, we offer support, but just to clarify, there is no Rohit CloudStack. There is no Shablue CloudStack. It's only Apache CloudStack. So I want to clarify this for everyone. Unlike OpenStack and other projects where there's a vendor-specific distribution, there is no vendor-specific distribution. I mean, there probably is, but that's not way near or close to the robustness and stability you get with this. So CloudStack is just Apache CloudStack. There's only single product that we ship. Even at work, as I said, we are one of the largest integrators at work. Shablue does offer support. You're not required to pay for support. You can still use the software. And of course, if you want support, that's not based on any kind of licensing, like product-based licensing. The product is still free. So a lot of vendors like Shablue, they're ethical in terms of being open source first. I would say us as an organization, We are an employee-owned company and an open source first organization. We never fork CloudStack. In fact, a lot of our customer work we do in terms of engineering and enhancements, we go upstream first. All our features, most of our features, even customers get from upstream. So we create an ethos where customer, users, and everyone are encouraged to become part of this model. I hope that gives you an answer. Thank you.
I see there is an CloudStack Slack community. What is the process to join it? Because I don't think it's a local.
That's a good question. So the question is there a CloudStack Slack community? How do I join it? Answer is we have a new website. You go to the footer at the end of the website. There's a link on Slack button. You click it. That should allow you to join that Slack group. If it doesn't, we also have a mailing list. So you can drop in an email and say, hi, I'm so-and-so. I saw a guy called Rohit give a talk, and I'm here because I have whatever question. We are a very welcoming community. We welcome anybody and everybody to come join the users mailing list, introduce yourself, and say, I have this problem. Or go to GitHub, and if you have any bug to report and suggestion around improvements, you can do that. Thank you. We can take one last question if anybody has any.
I guess we have one more.
Right. Thank you for the question. So the question is, now, what are the resources to learn more about integration of bare metal and Hyper-V with CloudStack? The short answer is a lot of these integrations, some integrations have broad support and some integrations have deep support. The integrations that have both broad and deep support, they just work out of the box. Some of the integrations, like you mentioned, bare metal and Hyper-V, they do work with CloudStack, but either the support is limited to certain versions or it requires additional expertise to set them up. All right, thank you for your time.